draw another triangle. Inverse sine, we're either in the first or fourth quadrant for our picture. We're going to draw a triangle in the first. So we'll do red theta. So sine is opposite over hypotenuse. So we'll have opposite 12, hypotenuse 13. And we can do Pythagorean theorem, right, to find that last side. A squared plus 12 squared is equal to 13 squared. So A is the square root of 13 squared minus 12 squared. So we get 5. To the right is positive, up positive, hypotenuse positive. Once you have your triangles, maybe refer to U and V using those triangles, right? Instead of U, say triangle, triangle. So we know we're going to go to the sine formula. So it's the sine of U plus V formula, right? So we know for that formula, it would be sine of U times the cosine of V plus cosine of U times the sine of V. Now I know in the U slot, I'm going to look at the dark triangle. And in the V spot, we know we're going to refer to the red triangle. So for the first part, what's the sine of the black triangle? So sine is opposite of hypotenuse, so 4/5. And then once we have that, we're going to find the cosine of the red triangle, so adjacent over hypotenuse of the red, so 5/13. Plus, so the cosine of the dark triangle, so we come to the dark triangle, adjacent over hypotenuse, -3/5. Times the sine of the red triangle, opposite hypotenuse, 12/13. So now when we simplify, we're going to get 4 times 5, just 20/65. So 20/65 plus -3 times 12, or -36/65. And we have -16/65. So basically, if you get stuck, if you don't see those angles that you recognize on the unit circle, try drawing pictures of triangles, and you're going to refer to those triangles. Let's try again in this next one. So for this next problem, we're also going to draw pictures of triangles. So we have, we'll do the dark triangle for this one, and we'll do red triangle for this one. So inverse sine 8/17. So we know that 8/17, sine is opposite of hypotenuse. So opposite hypotenuse, we know we're up here in first quadrant. We're either in the first or fourth for inverse sine. And opposite is 8, hypotenuse is 17. If we do Pythagorean theorem, we get 15. They're all positive, right? Up, hypotenuse are positive. Now if we draw the second one, inverse tan is also in first or fourth. So inverse tan, we'd also have another triangle up here, right? You could have them on top of each other, but it might be easier just to draw another picture. So tan is TOA, opposite over adjacent. So our theta is by the origin. Opposite is 5. Our adjacent is 12. If you do Pythagorean theorem, you're going to get the hypotenuse is 13. So now we have a dark triangle and the red triangle that we can refer to. This formula is cos of U plus V. and we have cos of u times the cos of v minus the sine of u times the sine of v. For the first one, when it says cos u, we know that the first dark triangle is u and the second triangle refers to v. First is always u, second is always v. So cos u, we're going to look at the dark triangle and find the cosine, which is adjacent over hypotenuse. So adjacent's 15 over hypotenuse 17. Times, now we're going to the V triangle. The second spot is V, or the red triangle, and the cosine for the red is adjacent over hypotenuse, 12 over 13. Minus sine of u. So u comes first. We have the dark triangle. Sine is opposite over hypotenuse. So 8 over 17. Times the sine of v. So v is the red triangle. Sine is opposite, 5 over hypotenuse 13. So you're going to get one fraction on the left, one on the right. So then we're going to get 180 over 221, 15 times 12 over 17 times 3, minus 8 times 5, or 40, over 17 times 13, 221. Since the denominators are the same, we can combine. And 180 minus 40, we get 140. Let's try the next one. So the next one's another solved problem. Now notice right in here, we have sine of u plus v. So I'm going to put a little u here and a v here. We're going to expand using our formula. So we're going to replace this. So sine of u plus v. We know that we'll have sine of u times cosine of v plus cos of u times sine of v. So if u is x, we're going to write sine of x times cos of v. So cos of pi is in the v slot, right? Cos of, in the u spot, it's an x, sine of v, pi is in that spot. Right, we're just plugging in. We're not drawing a triangle. They're not giving us ratios. They're not giving us 30 plus 45 and we're expanding. They're giving us pi, which is 180 degrees, and then that x, that unknown. So we're plugging into the formula. Now let's see. At 180 right here, we have negative 1 comma 0. So at 180, the cosine is negative 1. So this is negative 1, right? So negative 1 times sine is negative sine x. Sine at pi is 0. So if this is 0, then this cancels. So we have negative sine x. This turns to negative sine x minus sine x plus 1. So we have negative sine x minus sine x plus 1 equals 0. And then we have combined like terms, negative 2 of our sine x's plus 1 equals 0. If we subtract 1 and divide by negative 2, we'll have sine of x is equal to negative 1 over negative 2 is positive a half. So now we're going to spin around the unit circle and say, where is sine a half? Where is sine a half when we spin around the unit circle? At 30 degrees, we have root 3 over 2, comma 1 half. So at 30 degrees, or at pi over 6, we'll have sine value of a half. All students take calc. So we're looking for a positive sine value, we know, in first quadrant and in second. So we said 30 degrees, and if we reflect that, if we know this is 60, and this is 60, 90 plus 60 is at 150, or 5 pi over 6. So we know that our answers, where we're going to have sine positive a half, quadrant 1 and 2, it's going to be at 30 degrees, and 150, or pi over 6, and 5 pi over 6. Let's look at the next one. So right here, we see cos of u plus v. So we're going to expand this. We have x in the u spot and v in the pi spot. So we're going to write cos of u times cos of v minus, rewriting the formula, minus sine of u times sine of v. So I'm going to replace the x in the u spot and the pi in the v slot. So we'll have cos, and u is an x, so cos x times cos of v, so cos pi, minus, so sine of u, our u is an x, times sine of v, so sine of pi. So we're right now just doing this first part. We know that cos at pi is negative 1. So here this is negative 1 times cos is negative cos x. Sine at pi is 0, and 0 times that's gone. So all of this simplifies to negative cos x. So over here we're going to write negative cos x minus cos x minus 1 equals 0. We combine like terms again, and we have negative 2 cos x minus 1 equals 0. Now we add 1 and divide by negative 2, so we'll have cos x equals add 1, divide by negative 2, so negative 1 half. So as we spin around the unit circle, where is cosine going to be negative 1 half? All students take calc. So cosine is going to be positive in the fourth, so it can't be there. It's positive in the first. So we're going to look in the second and the third. Where is cosine negative a half in the second and third quadrant? At 2 pi over 3 and 4 pi over 3. Or you can write in degrees. If you forget, let's go to first quadrant and reflect. So where is cosine positive a half in first quadrant? At 60 degrees, right? At 60 degrees, you have a cosine of positive 1 half, and you have sine root 3 over 2. Sorry, the pen's not working very well. So here we'd have 30. So here's 30. So here's 60. If we reflect, this is 60. So when we rotate and stop at the first star, that terminal side, we have 90 plus 30, which is 120. And then we'll also have 180 plus 60, right? 180 plus that little sliver plus 60, 240. So you can write it